Properties of Logarithms, Part 1. Use properties of logarithms to expand each logarithmic expression as much as possible. Evaluate logarithmic expressions without using a calculator if possible. Here we have log base 7 of 7x. If we look at our logarithmic properties, we can see that our logarithm uses the product rule because we have 7 times x being multiplied together. Therefore, we can expand this logarithm into the sum. To do that, we'll have log base 7 of 7 plus log base 7 of x. Now I'm going to evaluate each logarithm if possible. Log base 7 of 7 is the same as 1. That's because we have a property that tells us that log of base b of b equals 1. So if the base and the number that we're taking the log of are the same, then our answer is 1. So log base 7 of 7 is 1, and then log base 7 of x stays as is because I can't evaluate that any further. Therefore, my answer is 1 plus log base 7 of x. Now I have the log of x divided by 10,000. If we look at our properties, we can see that our logarithm follows the quotient rule. That's because we have a value being divided by another value. Therefore, we can expand this into the difference or subtraction. Therefore, this becomes log of the numerator, which is x, minus log of the denominator, which is 10,000. Next, I want to look at each logarithm and see if I can evaluate that logarithm any further. So if I look at log of x, I cannot evaluate this, so it's going to stay as log x. Now I'm going to look at the log of 10,000. Now I can find the answer to log of 10,000. And remember, the log, if there isn't a base listed beneath it, then it's assumed that the base is 10. So this is log base 10 of 10,000. The exponential form is 10 to some power equals 10,000. Now, since we have 4 zeros behind our 1, I know that 10 to the 4th power is 10,000. So the log of 10,000 equals 4. Therefore, my simplified answer is log x minus 4. Now I have log of m to the negative 5th power. Since m is being raised to the negative 5th power, I can use the power rule to take the exponent out of the position and move it in front of the log. So this expression becomes negative 5 times log m, and that's my final answer.